The wind is a moving air mass. It can blow horizontally over the sea, or there can also be air masses with an upward motion. In this case, we talk about convective motions. Let us now add the two new elements. That is, the weather fronts, of which you can find a depression in manuals. But to keep things simple, we can just use one word. It's enough to say that fronts are clouds. These clouds would form in the warm air. So warm fronts are those associated with a warmer air mass, whereas the air bursting into the air is colder in the case of cold fronts. The two captains on board the two vessels are both going to observe a decreasing value of pressure as the centre of the depression indicated with the letter X gradually approaches. The pressure is going to decrease. The difference consists also in the direction of the wind and the transit of the frontal systems. We just said that a weather front means a cloud system, but we need to distinguish among the behaviours of the different fronts, depending on whether we deal with masses of warm or cold air. In our case, as we deal with a warm front, the change is going to be very slow and gradual. At this point, we certainly have the time to understand that the weather is changing. On the contrary, during the transit of the cold front, the weather development occurs in a rush. Thunderstorms break into the area, and therefore the change of wind will be sudden. We've noticed that clouds form any time the air cools down. This can also happen in the case of fronts in transit and applies to both cold fronts and warm fronts. We can see here this boat whose barometer shows high pressure. This is because the air column measured by the instrument is relatively cool, and we all know that cool air weighs more. As the warm front gradually approaches and the warm air moves over the colder, heavier air stuck to the ground, this is when the air column measured by the instrument will always be a little lighter. This is why, with the arrival of the mass of warm air, the atmospheric pressure is bound to decrease. As the air mass approaches, it is forced to rise to a high altitude, up to 6,000, 8,000, 10,000 meters, where the first cloud formations, the so-called cirrus clouds, will appear. These are the clouds consisting of ice crystals and are the first to form, followed by the cirrostratus, the stratus, and all the clouds that will bring about precipitation. We can, in this way, say that the warm front is a phenomenon that reveals itself gradually. The front at the surface could be approaching Spain, while the Ligurian Sea, where we are, will see a series of signs foretelling that this mass of warm air is arriving. This is the basic difference between the warm and the cold front. The cold front, instead, is generated by the cold air. As this is heavier, it will slot in under the mass of warm air, and the depression thus uplifts the mass of air, bringing the formation of these cumulus clouds with thundery outbreaks. In this situation, the cold front is nothing else but a wall of clouds peeping on the horizon with a significant increase of the wind, thunderstorms, and with marine weather conditions becoming very difficult. Another important element to observe is how pressure changes. Within the depression, we actually have a relatively low value of pressure. But with the arrival of the colder, heavier air, the barometer will show a rise. This explains the link between the wind, the pressure, and the measuring of our barometer. A characteristic feature of the transit of the cold fronts is a tail of the frontal system that meteorologists call the post-frontal sky. After the transit of the thunderstorms associated with the cold front, the sky generally gets brighter. You start seeing the coast at a distance. The weather seems to improve significantly, but there can still be a strong wind blowing. As time goes by, after the fronts have transited, there come the clear periods with just a few isolated cumulus clouds. That's the so-called post-frontal situation. This is the satellite image of the cloud systems affecting the Atlantic and our continent. From this image, you can clearly observe the large low-pressure vortex accompanied by the depressions, that is, its weather fronts. It's not easy to tell the warm front from the cold one, but one thing is sure. Inside this system, in its vortex, the cold front is quite neatly defined on the horizon of the image. And how can we recognize it? By means of the post-frontal sky. In this case, in fact, there is a marked contrast between the frontal thunderstorm cloud induced by the cold air from the northerly quadrants and the large clearings appearing after the transit of the weather front. This is the type of scenario showing up any time an Atlantic depression approaches the Mediterranean. Most times, the transiting low-pressure system stays to the north of the Alps. Other times, the depressions manage to affect our areas as well.